I'm Mark O'Neill, and I'm going to be talking about TrustBase, our architecture to repair and strengthen certificate-based authentication. And when I say certificate-based authentication, what I mean is the common case on the web here that's illustrated where you have a client application of some kind that is connecting to the internet and not visiting this little pop-up. There we go. Go away. Go away and stay away. Sorry. Well, we might just leave it. Whatever.
Why don't you just update it now?
Say that again?
Why don't you just update it now?
Just wait for it, yeah. Anyway, so as we know, there are lots of applications besides browsers that access the internet, just like that one. That's really annoying. And some browsers do lots of certificate validation correctly, but a lot of applications don't. And this situation here is very common on the internet, where the internet host will be sending back a certificate chain that needs to be validated by the client application. And the client application is responsible for doing a host of different checks. So it has to check the host name, make sure that's valid. It has to make sure that all the certificate signatures are valid. It has to make sure that it goes back to a root store entity, and that the validity dates are right, and basic constraints are right. And unfortunately, this problem in theory, or this whole situation in theory would work well. But there's actually two major sets of problems in this whole system, some of which I'm sure many of you are already familiar with. So number one is that the certificate authority system isn't quite as robust and resilient as we would like to think it is sometimes. And then the second one is that even if it was, application developers often don't do the correct checks anyway. And so I'm going to talk about both of those real quick. Number one here with the certificate authority system, there's a main problem here that, in my opinion, the biggest one is that pretty much every certificate authority that's out there can sign for any host they want, which ultimately means that the whole system of CAs is only as strong as the weakest one. And in the past, and not very recent past too, and for the last few years, in fact, there's been lots of instances where certificate authorities have been hacked, or for some reason they accidentally leak certificates. There's even been one that's accidentally posted their public or their private key online. All sorts of problems like that. And then, of course, there's also been those that have been hacked, like DigiNotar is probably the big poster child example of that, where some attackers got hold of Google property certificates and were able to intercept a bunch of Iranian Gmail connections. There's also been some recent evidence that certificate authorities are being coerced and influenced by governments for surveillance reasons. And not all governments are, of course, trustworthy, and I would argue that none of them are, in fact. But with all of that, still, there are some certificate authorities that don't even follow best practices. The most notable recent example of that's probably the CNNIC that was caught giving an intermediate certificate authority away to somebody who started, well, it was a company that started issuing a bunch of certificates for Google domains. Google caught that and removed them from Chrome's root store, but the CNNIC root is still in the Mozilla root store, for instance, despite Mozilla condemning that. So those are some problems with CAs. With the application developer side of things, there's also some issues. So there's been many studies that have revealed that there are some issues with validation of certificates on both mobile and desktop systems. And this isn't really something that's their fault, per se. I mean, there's a lot, like the field of computer science and software engineering is rather large, and you can go your whole career almost without ever knowing what a X509 certificate is and how to validate it and what it's supposed to do and all that kind of thing. And so it's kind of strange to put this burden on them to begin with. But on top of that, security libraries like OpenSSL are also pretty complicated. And even if you know what you're doing, it can be a little bit difficult. OpenSSL, for instance, has like over 300 different functions that are just like TLS SSL facing. And sometimes their names aren't really indicative of what they do. And so it can be pretty hairy to do. And then finally, of course, as an application developer, their primary purpose in life isn't necessarily to do just security, right? So they're introducing some new functionality. That's why they've got their app that they're creating, and that application is going to be distinguished likely more by its functionality than its security in most cases. And so it might not be a priority for them either. And so if we take these two problems in tandem and look back at our original picture here, this possibility arises where we have Emperor Palpatine himself standing in the middle between you and your Amazon account or whatever server you're trying to connect to, and actively tampering with your connection there. And then the reason that this works is because the certificate, the fake one that he's submitting to the application is being accepted because the application is not doing the correct checks, or maybe it's not checking host names only or something like that, and then or it could just be that it's a legitimate quote-unquote certificate from a CA that's been hacked or something like that. And then the problem gets a little bit worse because, as we all know, there are solutions out there that mitigate pieces of these things and kind of cover things like certificate pinning, OCSP responses, CRL lists, things like that. But these technologies don't get deployed system-wide. It's usually only in one application or another, and so there's a very fragmented space. And again, we're relying on application developers who may or may not even really have security as a high priority to implement these things. And even if they do, it's only going to be on their one application, not like all of them. So there's some difficulty there in getting things widely adopted. This happens in browsers too, and those are very security centered for the most part. But for instance, Firefox will check OCSP responses right now, but Chrome will not. And Chrome will have its own CRL set list that's kind of a proprietary CRL thing for them, but Firefox won't. And so if you want both of those technologies, you're kind of out of luck. So the real problem here is we look back at all three of these things with the CAs and the application developers and these alternate strategies for authentication, is that we've outsourced our trust decision-making process. We're relying on application developers who may not even really know about security to implement it. And as system administrators, system administrators have better insight into what kind of security checks need to be performed, and not application developers per se. And so really the question is, can we take all that trust that we've kind of outsourced to CAs and to application developers, and can we take that back? Can we own trust again and make our own decisions for our own machines and allow administrators to do that? And if not administrators, at least perhaps OS vendors to provide us with secure defaults and a nice way to secure that system. And the answer to that question is TrustBase. So TrustBase is our system that's motivated by the principle of doing exactly that. We want to take and centralize authentication as an OS service and put it inside the operating system where it can be applicable to every application regardless of how it was written and regardless of what the application developers may or may not know about security. And then on top of that, make that particular service respond to administrator preferences. And in that way, allow administrators to control very explicitly how all TLS connections are validated on their machines. And to do that, we had four particular design goals. So number one was we wanted to secure all existing applications without any sort of modification. There's been some previous efforts to do this, most notably CertShim, which was presented by Bates et al. And they did some things to secure dynamically linked applications for specific security libraries. We wanted to take this a step further and just mandate that it would be every single application on the machine getting validated. And then a very related goal to that is also making sure that applications can't opt out of it voluntarily or otherwise, right, to bypass any sort of checks that the administrator might want to perform. And then we also wanted to provide a platform for strengthening technologies or even alternate technologies to the CA system to be deployed and run by our system, our TrustBase. And with all these three things in mind, we wanted to make sure that it was also had negligible overhead so that it would be performant and usable by people. So the first step of that is just moving trust to the operating system to begin with. And we chose to put TrustBase is right in the middle of the application layer and the transport layer of the operating system. And this enables it to dynamically, transparently intercept all certificates that are being transmitted to the client machine, extract those, and send it to an independent operating system validation service that will issue yes or no responses in terms of whether or not that particular certificate chain is valid. And we have prototype implementations ready for Linux, Android, and Windows. Our Linux implementation is the most mature, so I'm going to be talking most about that one in this talk. Here's an overview of our TrustBase architecture. There are lots of components to this. I'm going to be going over some of the salient ones right now. But I'm going to start here in the unmodified application box. So we have an unmodified application that creates some sort of internet socket to connect to some remote host through TLS or maybe not through TLS. And the first thing that TrustBase does is redirect everything through the traffic interceptor. So the traffic interceptor is a loadable kernel module. Doesn't need any sort of, you don't have to recompile your kernel or anything like that. You can just insert this dynamically at runtime. And then that module's job is to export what we call our handler API. And so it hooks into the transport layer of the operating system and makes sure that all of the different socket calls that someone could create are going to go through that particular API, which allows a handler to see that traffic, modify that traffic, or do whatever it wants. And so we've created a TLS handler, and that will communicate with our traffic interceptor. And the TLS handler's job is simply to look for TLS records that are being sent back and forth between two internet hosts. And then if it finds that that connection is speaking TLS, great. If that connection is not speaking TLS, it'll just immediately ignore it and send everything back through the control flow path of the original operating system structure. But if it is speaking TLS, it'll wait for the whole handshake to be complete and then pause and suspend the connection. And when it pauses that connection, it takes all of the certificate chain data and other data that it's collected that far and then sends it to a local daemon that we call the policy engine for a validation decision. If that validation decision comes back that, yes, that certificate chain is valid, it stops monitoring that connection and allows everything to continue as normal. If it comes back as invalid, it'll do two things. First, it actually just messes up the certificate chain so that way if the client application has some sort of built-in errors, it can display that to the user. So it's like a more SSL-oriented error. And then after that, it'll close the connection. And so if we just close the connection, we lose the opportunity for things to say things like SSL error instead of connection reset by peer or something like that. So that was more for user-facing usability purposes. So the policy engine is the daemon that's responding to all of the requests from the TLS handler. And basically its job is to just receive those queries and respond to them. It can also receive queries from userspace if you have a desire to make an application that calls TrustBase's validation functionality natively. And so it receives those queries via netlink, and then it also implements as just inside of itself basic CA validation, the kind of validation we should all be doing when we validate certificates, on kind of like the minimum bar there. So it checks host names, and it makes sure that the signatures are valid and the basic constraints are correct and all that kind of things. The other thing that it does, though, is it allows other plugins and services to be deployed onto it that will do additional checks or even like replacement checks for validation decisions. And it can place these authentication plugins into one of two camps, the necessary group or the voting group. Plugins that are deemed necessary must say yes to a certificate for the final aggregate decision to be yes. And then the voting ones have to meet some particular threshold set by the administrator to get a full yes out of that. And the administrator is free to configure that how he or she would like. The last part that I'm going to go over of our TrustBase architecture is the plugin API. The plugin API is essentially two pieces. One piece is simply just the actual plugin part, where we allow both asynchronous and synchronous plugins to be connected to the system and receive data about certificate chains and hello data to make their decisions. And each plugin can say, yes, this chain's valid, no, it's not, abstain entirely, or report an error. And then the abstain and error messages can be mapped by the administrator through a configuration file to yes and no, depending on what he or she would like. The add-on API that we have is so that we can write plugins as researchers in whatever language of our choice, so we can do rapid deployment of various new ideas that we have for certificate validation. So we've created a Python add-on that allows you to make plugins in Python. You can also do native C plugins, but if you have a desire to do one in like Rust or Go or something, you can go ahead and make an add-on for that language, and then the plugins will work for that language as well. So we've included a few plugins with just the basic prototype of TrustBase. The CA validation one, like I said, is built straight into the policy engine. And what's nice about that is that it now covers CA validation the correct way for all applications on your machine, regardless of how they were written or what library they were linked with, and how much the developer cared about security. We also have a certificate pinning version, which is like CA validation, but a little bit stricter, where we require that the subsequent connections from a connection use the same exact certificate that the first one did until it expires or until the administrator wants to clear that. And we also have OCSP checking and CRL set checking. And this is kind of nice because CRL sets were kind of like a Google proprietary thing until this. And so now if you're a Firefox user, you can actually have access to the CRL set functionality that Google provides. And then same thing with Chrome. If you're a Chrome user, you can now get OCSP checking. We also have some technologies that are a little bit further removed from the basic CA system, such as Dane, which uses DNS records, Notary, a plugin that is loosely based off convergence, which will use like notary agreement on the internet from different vantage points to establish some sort of consensus about whether or not a particular certificate chain is valid for a given host. And then finally, we have a Cipher suite auditor as well, which has nothing to do with certificates at all. In fact, it's just using the hello data that we present to plugins to make sure that the Cipher suite that was agreed upon between the two hosts is up to administrator preferences. And if it's not, then it'll send back a no, abort this connection type of response. So that was all about how we've managed to get a degree of coverage in the operating system for all applications and deploy a platform that enabled different types of authentication services to be deployed. And now I'm going to talk about a little bit of our evaluation of that to make sure that we can meet our fourth goal, which was negligible overhead, and of course our first goal, which was 100% coverage. So first I'll take a few moments to talk about just centralization in general. So centralizing trust like this into the operating system has pros and cons. The greatest con is probably that we've now introduced essentially a single point of failure. So if that breaks, then the system just as a whole breaks for every application there is. The nice thing is if an application is currently doing all the checks it should, it's not like we've broken things further. We just kind of missed an opportunity to make things better. But there's also some upsides too, and that's that updates are also global. We can have a lot of eyes on this one system now that is open source and public now. We've posted the code. So people can enhance it, make it better, and if there's a problem, we can fix it for all applications simultaneously rather than making like 40 different changes in a bunch of different applications, some of which we don't even have the code for to begin with. So this is very much in line with what we've done with operating systems in the past, right? We don't expect like application developers to like write their own TCP/IP stack or write their own virtual memory system when they want to make a memory access or something like that, right? Like, there are some services that are out there that need to be used by all applications and need to have some sort of administrator control. And we would argue that validation of certificates is definitely one of those things. And so this is very much in line with previous things like that. You'll see here on the table on the right, this is kind of a superset of what Bates et al. Tested their services with. So we went through like all the different libraries we could think of that use TLS and SSL and a bunch of different tools as well, and made sure that things that we wrote with them would respond exactly how TrustBase indicated that they should based off our configuration files as the quote administrator. And we found that in all cases it does, which is expected behavior given our position in the operating system, since we literally have access to all traffic being sent. We also took some additional steps to harden the system against local attackers and just maybe some like application developers who didn't want their application intercepted and validated independently. And this is something that we needed to consider because our work in the past and some work from others has indicated that local man-in-the-middle proxies for TLS connections are actually more prevalent on the local host than they are in remote entities. And so we wanted to make sure that we were protected against local malware that might be looking to subvert TrustBase's checks. So the first thing we did is we made sure that only administrator enabled, or rather privileged applications could remove TrustBase from the kernel. And then on top of that, we made sure that if there was the only way to bypass TrustBase's checks is if the administrator has set the net raw capability on that particular binary. And then we also made sure that the policy engine that runs answers queries from the kernel and responds to them, or gets them and responds to them, had to have the net admin capability. So that way we make sure that the things that are listening to these queries and responding to them are things that are at least run by administrators. And then the last two things is we made sure that the daemons that are run only use configuration files that are writable by admins, and then run as non-root with only the capabilities that they need to run to do their job. From a performance side of things, we tested both the TCP handshake latency, the TLS handshake latency, as well as a bunch of file transfer times with and without TrustBase enabled. And in our case where TrustBase was enabled, we ran basic CA validation plus our pinning plugin, just those two. And we found that in all cases in our simulated network, well, it was a local network environment, that network noise, even in that environment, accounted for much more variation than the differences in the added functionality from TrustBase. So we really accomplished our goal in terms of negligible overhead. Not only is it negligible from a human perspective, but even measuring it from a computer was like all over the board, and there was a lot more difference in just general noise than there was in our added functionality, which was really nice. Because what that meant is we accomplished our 4 goals. And so we've got a bunch of different applications now that can be secured by system administrator preferences. We have a platform for new authentication services to be deployed, and we've done all of that without really adversely affecting the system. So in future work, we want to go ahead and take this just a little bit further. We've talked about putting TLS certificate validation into the operating system, and now we want to put TLS into the operating system. And one really nice, straightforward way to do that would be to extend the POSIX API as it is now for sockets and do something like I have here, this line of code at the bottom, where we, instead of saying something like IP proto TCP, you instead specify IP proto TLS, and then you treat that socket as if it were just a plain text socket, do whatever it is your application is supposed to do with the internet, and then let the operating system handle the entirety of the TLS connection behind the scenes. And that includes things like what Cipher suites to pick, which we can't do currently with TrustBase because the application's kind of picking that and we're saying yes or no to it, as well as what version of TLS to use. Like maybe we could even upgrade everything to TLS 1.3 this way. And then also it can call TrustBase's validation function behind the scenes for everybody. So this is a nice way to go forward in our opinion, and we actually have close to a working prototype with it, so that should be coming up shortly. And then I think this is also just something that would be very beneficial to system administrators because they can actually have more control over how TLS connections are done, but also application developers who now no longer have to like explicitly link with some security library, make sure it's the right version of something, and then like learn some complicated API. They don't even need to worry about that. It's just like they don't need to worry about TCP or like the file system. They just say, yep, I want to make a secure connection, and that's all they need to do and think about. So in conclusion, TrustBase is a system that lets you trust who you want, how you want. Thank you.
Great. Time for questions, and please do remember to use the mics and state your name.
Hi everyone, Farshad. I'm with B-Sides Vancouver and Mirai Security. Great space to address. I've had lots of experience consulting to application teams not doing this stuff correctly, so this is a really good thing that you guys are doing. I noticed you mentioned certificate pinning. Are you guys doing classic pinning or HPKP?
Oh, so classic pinning.
Classic pinning. Are there plans to support public key, HPKP at all?
I didn't quite get that.
HTTP public key pinning, HPKP.
Certainly it could be done. But I haven't done that.
Okay. Yeah, because we noticed, like, we analyzed about 1,000 different teams at the organization. I consulted for a very large financial organization, and classic pinning caused a lot of issues with, if there's an issue that they need to revoke, they would have to redeploy and all kinds of other stuff. And HPKP seems to be the standard way that the industry is going. So I was wondering if you support that. But great product.
Thank you.
Hi, Hugo Vincent from ARM. Just had a question I didn't quite understand from your presentation. Does this system still permit applications to make more strict decisions than TrustBase policy requires?
Absolutely, yes. Right. So that's kind of the size there. You have that right on. So.
Okay, thanks.
Hi, Tom Dwyer from Oracle. You mentioned that you detect or you watch the handshake, and if it's not a TLS connection, you just let it go. I'm wondering if you considered the case of start TLS, where TLS is added after the fact, sometime long after.
Yes, so we actually do have a prototype of our start TLS handler as well. Specifically, that one's built more for SMTP, but that option is there, and we've tested a start TLS handler as well with that. And that's included in the code as it is.
Great.
Yeah.
And these two questions and then that.
Okay, Greg Zavrucha, Microsoft. So my question is about unmodified apps.
Okay.
Well, two questions actually. So one, some apps don't want to use the system trust store. They'll just ship with their own root cert that they validate up to. So that's one question. How do you deal with that? The other one is, have you seen apps that, if TrustBase rejects the connection, the app falls back to an insecure connection?
I didn't quite get the second one, but can you restate the second part?
Yeah, so you have an unmodified app that tries to make a secure connection with TrustBase. TrustBase rejects it, and then it just falls back to unencrypted.
Yeah, no, we haven't actually considered that second thing, so that's something to look into. But in terms of your first question, which now it's blanking on me. Sorry, what was your first part again?
So apps that ship their own root.
Oh, yeah. So that's something that we would expect that if a system administrator notices that, and he expects that like maybe they're just doing like some sort of pinning because they've got like one thing in their own local root, that he would just allow them to just bypass TrustBase's interception by setting the capability for net raw on that particular application. We also have something so that if you're using the system root store and you want to actually reject, like if you want an application to accept something that it would otherwise reject, we can support that too. Using an optional local TLS proxy that we can run, and we redirect traffic from the kernel through that, and that has a root store optionally. That modifies the root store so that the application will be forced to accept it in that case. But that's an optional piece of things.
Yeah, thank you.
And this side.
Okay.
Hi, Bill Soley, Apple. I was wondering how you pick up the domain name to compare for the certificate, since that's not part of the API.
Right. Yeah. So the nice thing is most applications we found, even broken ones, are using SNI these days. So if it's present, if the host name is present in SNI, we grab that. If not, we have a modified version of PDNS that will just do passive DNS logging and try to infer the host name from that. And if that fails, we'll just use the IP address because that's all we have.
Okay. Thank you.
I actually had the same question. So.
Okay. Great.
So we know, sorry, I'm Joe from Caltech University. So we know with browsers taking care of these things these days, there's a lot of pages with mixed content and like all of sorts of different symbols displayed to the users. And does that take care of it, or like how's that handled?
So in this case, if we're talking specifically the case of browsers in this case, yeah. So it'll do a little bit of weird things right now as it stands. So when I run TrustBase and like for instance, let's say some external CSS fails some validation from its remote host, but like the rest of the page content is from a different host and it works fine, then it's like the CSS just won't load. And so you'll see a pretty ugly looking 90s style page instead. So we don't have anything that presents to the user currently in Linux at least some sort of nice error warning. It's like, okay, this is why the page looks funky. But in Windows we do actually have our implementation there has a nice little notification thing that'll pop up and say, okay, like if things look weird, this is why, right? And it'll explain what's going on.
But do you plan to support that though, or is it going to be the case that yes, if a page with mixed content is going to be just prevented from being displayed and that's it?
Well, if it's got mixed content, we're already going to prevent the stuff that's not supposed to be there. So, but I don't know if we have any plans to like make a more explicit user-facing notification about that. Yeah, thanks. Yeah.
Great. Well, let's thank Mark again, and I'll see you in a second.